Hello and welcome everybody. Today I would like to show you how to do some engineering. I will be making a shelf to store a raw material in the garage or a workshop. Key in this project is doing it the right way. Designing a shelf is fairly simple engineering task, and I'm going to show you and explain my approach to this problem. So, without further ado, let's bounce. The first thing I always do is a research. This plays a major role in any project. For this project, I will be looking into three topics. First, recognize the problem. Second, look for the standards. And thirdly, look for availability. Let's jump into the first point, recognizing the problem. You have to have a need for storage shelf. Basically, the need for such a shelf may occur when you are working on some project that requires standard size cross-sectional area of raw material. For example, you are building a table and it requires an L bracket for the corners, let's say 20 millimeters in length. So you go to your local Home Depot and find 1 meter long L bracket as the raw material and 20 millimeter pieces cut to size. And you know that for your table you're going to need just 8 20 millimeter L brackets. Then you are starting to look at the prices and you see that the long one is the same price as 3 short ones. It happens very often that buying a raw material and cutting it to size that you need will cost you significantly less than buying cut to size pieces. And you will have a lot of leftover material from that raw piece you just got. Therefore, it would be in your interest to buy in bulk, cut it, and store the remaining portion for the future projects. I think many of you have faced this problem a couple of times, if not more often. Or you might want a storage shelf if your garage or workshop looks like my old one. So there you go. These are some aspects you should think about to recognize that this is a problem for you. The next stage is about the standards. All raw metal parts that are standardized have constant cross-sectional area throughout this length. And a lot of extra information is available if you know what standard your material applies to. Those standards are being made by standard organizations. In all major areas in the world have their own standard organizations. In the US you would see ANSI standards, in Europe ENDIN, in UK BSI, in Japan JIS, and ISO for international. I'm not saying you can't find other standards outside that region, but this is something to keep in mind. As well, these are not the only standards there are in the world. There are many more. These are just the biggest ones I know. By knowing what standard applies to certain material, we can determine the application it can be used for. To make it a little bit simpler for you, I like to think about the standards as a very strict quality control in manufacturing process. By knowing these standards, we can determine very precisely what is the material, chemical, mechanical and metallurgical properties and use that engineering data to our advantage. For more information about these standards, check the links in the description below. Now, let's take a look at some raw material suppliers. This supplier is Danish. I show it because I'm located in Denmark. Now, let's select a random application and let's go to random material. Over here we can select the outer diameter of this. Yeah, and let's just select the random one here. And here it asks for the length of this. This means that the cross section throughout all the length that we select over here is going to be the same. Let's see what would be the price for the shortest bar. Here you can see for the shortest one we have 200.7 Danish krone. And if we would buy 10 times larger piece, the price would be 252 Danish krone. So if we pay 51.3 krone more, we got 9 times more material. This means that the price is not scaling linearly. Now I'm curious how much would be the longest piece. It is 366 Danish krone. To summarize this, I have made this chart. You can see to get 10 times more material we have to pay extra only 51.3 Danish krone. To get 2 times more material than that we have to pay 114 Danish krone more. Usually on the bottom of the page there is like a description as we have over here. Unfortunately I don't see the standard they used. For this piece, all we have is the steel type, which is S235. To make a shelf, that information would be enough. Generally, you would like to select the supplier which gives you the most information about the materials. By not knowing anything about the materials you are about to purchase can result in over-dimensioning or under-dimensioning, as well as you have no information about the weldability of the materials. Since the price in general satisfies me, I'm gonna stick to this supplier. So the next process I usually do is idea generation. Now, in this phase, the goal is to come up with conceptual idea of how you would like your shelf to look like. There are many ways you can do this, like searching web, going to exhibits, observe your environment, or even talking to someone about your ideas. It is always in your interest to get as many ideas as possible, and there is no bad ideas in this phase. If you have an idea that in your opinion is totally useless, it is still good because it might trigger other ideas that might turn out to be really good. Let me show you how I would do idea generation for this project. I'm going to do a web search. The sites I'm always checking are Google and the Pinterest. I always try to search using different keywords. Like in this case, I might look at the storage rack, material storing solutions, automated material shelves could be interesting. This is very fundamental phase in any project. It happens very often to me, and I think to many of you, that once we come up with a project, we already have general idea of the design in our mind. This is bad, and let me tell you why. If we are skipping this phase, basically, we are limiting our creativity to only one design, and many other options are never even considered because we never knew they can be implemented. It is okay to have a general overview of how you want your project to look like or function, just don't stop there. There are always so many extra things we can easily add to make our product even better or more practical. It doesn't mean you have to implement all of them, just consider them. And even if you're not implementing those ideas in your current project, you would at least know that they exist, you would acknowledge it, and maybe you would use some of it for your future projects. In this phase, you should spend quite some time because you want to generate as many ideas as possible. And remember, in this phase there are no bad ideas. Even the idea you have might sound ridiculous, it's still good. Also, there are no such thing as too many ideas. So please, never ever skip this phase. After you have found a couple of ideas, it's time to move to the next phase, which is concept development. At this phase, you have to answer some key questions. But before that, you have to come up with these questions. Those questions usually comes when you think about, first, what might go wrong, and second, what could cause the problems. Let me give you an example of questions for this project. First, how much space do I have in my garage or workshop? How I'm going to access my material? How I'm going to add or remove material from my shelf? Am I going to use a machinery or I'm going to use my bare hands? How often I'm buying new materials and resupplying my shelf? Is it likely I would buy materials I have never bought before? Having those questions in mind, try to combine ideas you got in idea generation phase. You should reduce the amount of ideas at least by half. And there you go. These are essential steps to start any real engineering project. For the recap, here are all the steps I discussed. I started by doing a research where I was trying to recognize the problem, I was looking at some standards, and finding a material suppliers. Then there was idea generation, where I was trying to come up with as many ideas as I could. And finally, I tried to develop my concept by taking out the ideas I could not use in my environment or didn't fit my purpose. In the next episode, I will be putting up some important numbers, so please consider subscribing and stay calibrated.